So good morning, everyone. My name is Gabriela Ragowska. I'm from Trust IT Services, SEEBLOCKS. And today I have a pleasure to welcome our speakers and all the attendees at this webinar on the decentralized public key infrastructures and blockchain. So at the just some rules, some housekeeping rules. This webinar is recorded and the recording will be shared afterwards on our website and YouTube channel. You have a chat box and the Q&A box. So in the chat box, we will send you some interesting links of the initiatives that we will be talking about. And in the Q&A box, you can type your questions that we'll address later on in the Q&A section. And our speakers can reply to you. So just don't be shy and use this tool to ask the questions. So today we have Eric Anderson with us, who is a SEEBLOCKS fellow. Eric is currently working on an extension to the recommendation TX 509, so the standard on public key infrastructure. So we are very happy to have him here, and we look forward to his inputs on the work that he's running for SEEBLOCKS as a SEEBLOCKS fellow. And we have Raimundas Matulevicius from University of Tartu, Estonia, and a representative of Chase and Chess project. So we are happy to have Raimundas here. We are also looking forward to know more about the Chess project. And Raimundas will introduce us to the decentralized public key infrastructure for X-Road. Unfortunately, Marcus Sabadella cannot join at this point, but hopefully he will join later on. If not, you can. Oh, he's here. Okay, that's good. So Marcus is an expert in the field of the digital identity and a co-editor of the Decentralized Identifier Specification at Wide World Web Consortium. So, and Marcus is also SEEBLOCKS fellow. So we're happy to have you here. We are also looking forward to know a bit more about your experience as a SEEBLOCKS fellow. So, and obviously about decentralized identifiers. Okay, so good. Just a very quick information about SEEBLOCKS. You are probably very familiar with the project, but just a few words about it. So SEEBLOCKS is supporting a European interest in standardization within the blockchain domain. So we want to make European voice stronger and in the standardization of blockchain efforts. And for this reason, we are funding experts, fellows like Eric and Marcus to support their efforts in standardization. So we have 4 open calls for selection and engagement procedures with a budget of 300,000 euros. And now actually we are running the final calls, the 4th call, which is closing on 22nd of July. So I will talk a bit more about it later. And SEEBLOCKS is always has as well a visualization tool. We are providing visualization tool, a great repository with documents, videos, slides, materials on blockchain standardization. So you can find there many great resources for the beginners who want to know more about the standardization, and for the very experts of blockchain standardization. So we recommend to give a look on our website when you can find the tool and the resources in different languages. We are also delivering the landscape and gap analysis report. And actually now the second open public consultation is open. So we are inviting you all to participate in the open consultation, which is the step to develop the report and to ultimately contribute to the blockchain chapter of the rolling plan of standardization. So here you have some features from the selection and the engagement procedures. As you can see, in the first SEP, we have funded 8 experts, and the same in the second one. The third one is now under evaluation, and the fourth is open now. So we have received 55 applications from 17 countries. And we have already funded 16 proposals for a total amount of almost 150,000 euros. So as I said, the final SEP is open. We will put the link to the final call now. It's open for individual experts in blockchain standardization. You have you can get up to 10,000 euros for your activities. There are 3 different types of proposal we can find. It is one shot, short-term and long-term, up to 6 months of activities. And as I said, the second open consultation is open as well now for the public input. So if you are a blockchain expert or an industry expert or standardization expert, we are very welcome you to contribute to this and to participate in the open consultation, who will ultimately contribute to the report. In the visualization tool, as I mentioned before, it is available for all of you on our website. So these are the topics that we will tackle in the webinar today. And so firstly, I will ask Erik Andersen to talk about the AX 509 standard and how the public key infrastructure based on blockchain and his activities in this regard. Thank you, Erik. Then afterwards we will have Raimundas talking about X-Road and DPKI, and Marcus Sabadello on the standardization of worldwide consortium decentralized identifiers. Thank you all. Okay, and Raimundas, so if you can share the screen, I will. Yes, the stage is yours. Thank you.
I'm sorry, I thought Erik is starting. Yes.
Yes, Erik, absolutely. Thank you.
It's not showing yet?
Yes, we can see.
You can see my screen? Okay, good.
Yes.
Thank you. Thank you. And I will start. And first, just say to start off that public key infrastructure is about trust, it's about identity, and we are also continuing now on having privilege as a part of PKI. Currently, it's a separate section, but to also have privilege means access control support in PKI using attribute certificates, which I will return to in a little bit. And the reason for going to a blockchain solution as an alternative to the current way of providing PKI is that it's difficult in the current PKI to actually have a common trust. In the current specification, we have a third-party trust, and in the worldwide PKI, it's very difficult to find a trust as from a third party that everybody trusts. So we decided that it could be useful to have trust by consensus, and that's what led us to select PKI, no, DPKI, based on blockchain. So the approach we have taken is to say that it is to be an international standard, and current blockchain platforms cannot be used as a normative reference. They are privately owned, and we cannot control them in any way. So, but we have decided that current platforms could be used as an inspiration, so we don't have to invent everything ourselves, but can kind of copying from what others are doing. And one of the things we have been looking at is Hyperledger Fabric, which seems to be a reasonable choice. It's a business type of platform, and there's a lot of documentation and so on. And it includes a state database, and I think that's important for our approach. And we are also considering the Stellar Consensus Protocol for the Consensus Protocol. But much of the specification will PKI specific, because the intention is to make sure that the information that's in the blockchain is reliable and proved, so that people can trust the information that's in the blockchain. So there's a lot of checking of things before they are allowed to be added to the blockchain. And we also make sure that we are able to migrate the cryptographic algorithms, which is probably a lack in most of the platforms today. That when we see the quantum computers coming up, they will not be able to migrate. Okay, I will continue quickly. And the idea is that we have what we call certification authorities. That's the issue certificate. They are not part of the network itself, but are attaching to a node. That means the CA can continue its normal operation and the only thing it has to add is an interface to the blockchain, to a node that then is identifying the CA itself. So that's the idea, that the CAs are not redefined, they are the current CAs. And a note, this is an overview of the general architecture. So it's not only CAs that are accessing the blockchain, it's also those that can issue attribute certificate, and they are primarily used for access control. And also, of course, those who need the information can access information from the blockchain. They are in the PKI called relying party. They are depending, their action out is depending on the content of a certificate. And this is the overall picture of a node. And the main thing is that we have this DPKI directory that maintains the status of the different certificate that's stored in the system, so that people do not have to go through the whole blockchain to see what the status is of a certificate, but we keep the certificate in the directory, which is also distributed. And then, of course, it has communication with the peer-to-peer nodes. And some of the things here I have already said, that, but only certificate that's of interest outside the local PKI should be inserted in the blockchain, so we don't fill it with a lot of things that not having a global interest. And also short-lived certificates should not be inserted. And revocation information. For those knowing PKI, revocation is a problem in itself, but we have revocation information as part of the DPKIs. So and there's a more detailed picture of things that we have this thorough checking of everything come from the CI or from the AA, the attribute of sources. And we have a lot of other things going on. I think one of the main thing is this configuration file that's keeping information about the whole DPKI. Otherwise, there are module for transaction generation and validation and so on, and from directory access, and the relying party can access to their own module here. So that's the overall structure, and I will come back a little more to that configuration file. And there are different type of public key, cryptographic algorithms. As you can see the list here, we need to have for those that are familiar with blockchain will know there's a lot of cryptographic algorithms necessary for running the blockchain. So, but we have then the list of the current algorithms listed here. So every node knows what kind of algorithms are going to be used. So it's not fixed from the beginning like many other platforms. It's a cost. You can customize it, and in addition, we have put in the possibility of having an alternative algorithm. Here's the example from a public key algorithm that is used during a migration period, especially when we come to the blockchain. No, sorry, to the quantum computer problems that we probably need to move to quantum safe algorithms. And we have actually established procedures for doing that. So that goes for every type of the algorithms we are going to use. And everybody in the chain knows what to do and what algorithms to use. And in the migration of the hash chain, this is something we hope is going to work. There has to be checked very carefully that it works, so that even if we, during the operation of the blockchain, changes the hash algorithm, we can still check the whole hash chain by having in the migration block, as we call it, information about the old hash, so you can still check the hashing chain all the way. So and quite shortly, directory structure in the PKI about all the different type of certificates, the CA certificates and user certificate that's used outside the blockchain, and different type of public key certificate that's used inside the blockchain. And here is and suggests the structure of such a directory that external users can access. So and that's kind of summarized here. That we describe it in X500 directory specifications, but that easily mapped to LDAP. And what we actually are obtaining here is a distributed directory based on LDAP. And so that's an LDAP is quite a simple and well-known directory structure. So yeah, I think that's what the time allows. So just to say, there's a lot of work to be done to get it all in place, and so I think I will stop my presentation here. Thank you.
Thank you very much, Eric. Very appreciated. So now ask Raimundas to share his presentation. If you have any questions to Eric, just type them in the Q&A box, or you can have the possibility afterwards to ask your question in the Q&A panel. So Raimundas, the floor is yours. Thank you.
Thank you. I'm trying to find how can I share. Somehow now the button disappeared. Just a minute, I will figure this out.
No problem. If you have any issues, I can share the screen on your behalf.
Oh, here myself because I have a new version of it.
You
Okay,
should see.
now I found it. Good.
Oh, that's good.
Do you see my screen?
Yes. Yes, yes, let's do it.
Very good. Just a minute, I will do this full screen. Okay, so now I'm ready. So hello, everyone. My name is Raimondas Matulevičius, and today I will present you a work on the decentralized public key infrastructure for the X-Road. And I should say that this is a joint work of two countries, I would say, because we participate in the Excellence Hub on the cybersecurity in Estonia and South Moravia. And this is the Excellence Hub, which is formed between these two geographic areas, and we do work a lot within the different topics of the cybersecurity. Security preservation is one of the topic. Security preservation using blockchains on the blockchains is one of the topics. And of course, one of the aspects which we do here is also on the decentralized public key infrastructure. The work basically is done by Maria Bakhtina and Kinlon Cleo. And here I'm just a messenger to distribute the results and to inform and to show some nice experience and an example on how we have designed the system, how we have used it. Okay, I will present one use case. And the use case, it comes with the use of the X-Road, which is an open source solution that acts as the data exchange layer between the information systems, enabling organizations to communicate securely. X-Road is the backbone in Estonia and quite a number of other countries as the digital government infrastructure. Within the X-Road ecosystem, members consume and produce service to another member via self-deployed or trusted X-Road security server, which is responsible for access control and the signing of different messages. Currently, X-Road relies on the centralized rules of Rust and centralized identity management. Public infrastructure with the protocol X.509 has been as the de facto standard for the trusted establishment between the information systems. Except for the proneness to the single point of failure, the problem with the existing solution is the lengthiness of the new member onboarding, which relies on the member identity setup and may take for the few hours to months. If the organization wishes to join an X-Road ecosystem, it has to obtain the certificates from the central authority for signing and authentication. The process can take time due to the need for manual verification. Thus, it depends on the central authority and also the online certificate status protocol, which brings limitations to this X-Road. And in addition, certificate authority and its certificate revocation status distribution mechanism has also suffering some scalability issues and has the vulnerabilities regarding the DDoS or replay attacks. So basically, we try to target this approach with problems by introducing self-sovereign identity, which has basically, which brings some new novels and which brings two very important standards. The first standard is named Decentralized Identifier, Decentralized Identifier, DID, and it is a global, unique, persistent identifier created and controlled by the entity without the help of the centralized authorities. And this method usually is being supported and created by the use of the distributed ledger technology. In this example, basically, we see that the DID, how it is being used in the Ethereum network. One can resolve the DID document from the blockchain, which contains key materials for proving the ownership of the DFD. Another SSI standard is verifiable credentials. Verifiable credential is a tamper-proof credential with the authorship that can be cryptographically verified. verifiable credential can be presented as verifiable presentation. This separation between the two definitions enables features like selective disclosure and zero knowledge proof, and basically it contributes to the more flexible trust establishment process. So basically, since the release of these two concepts, there have been different open source implementations actually. And these new technologies basically motivate to look for the decentralized public key infrastructure establishment, what uses DAD, uses VC, verifiable credentials, and also the distributed ledger technologies to address the limitations of the public key infrastructure, which is currently used in this X-road. Okay, so what was the questions and requirements which we have analyzed within this use case? So our goal was to understand on how can we establish trust between the information systems and using the decentralized public key infrastructure. And what are the goals here? What are the requirements? Firstly, we create this new design, and it should increase the degree of decentralization. In the new design, the two information systems should be able to establish a trust, secure connections without any centralized service. Second, the new design should provide more granular access control mechanism, which will be attribute-based. It is improvement compared to the existing X-road, in which access control is implemented based only on the subject's identity. And the second requirement is that the new design should support automated member onboarding using verifiable credentials. Let's see how we have implemented this, how we have designed this. Basically, in this slide, I'm showing you the two different designs of the system. This X-road original architecture, which is as is right now, and also the X-road with the DPKI infrastructure, which it serves for us as a proof of the concept. So in the original design, it uses the centralized online certificate status protocol for certificate revocation status resolution. In contrast, all the information required to verify the credential can be obtained in the distributed ledger through the decentralized node as illustrated in the new design. Another important aspect, it comes with the introduction of the so-called SSC agents, which are controlled by the organizations. These SSI agents implement protocols to connect with other agents and secure the storage of the credentials commonly known as wallets. As a result, the SSI agent takes away a part of the responsibilities from the original X-road security server. Coming back to the implementation, so for the proof of the concept implementation, we implemented a simplified instance of the X-road security server and centralized and central server, just to illustrate how actually it can work, and you can get this implementation from the freely available from the GitHub. What are the key concepts of this implementation? So the key concept is that the X-road components are integrated with the open source SSI software, including Hyperledger Indy as the distributed ledger for recording DAD documents and revocation status. It also uses the Hyperledger Ares Cloud agent Python to manage credentials and the connections. It also uses the uncreds technology for verifiable credential implementation. And in the end, we also have used here the Ares protocol, which helps to build, which is built on top of the lower level protocol named the DAD-COM, which defines the procedures to establish the trusted connections using authentication keys in the DAD documents. And now, basically, so as I have illustrated you the design, I have illustrated you the key principle of the architecture itself. Let's look also for a very short demo to understand on how the architecture itself, well, how the prototype, how the proof of the concept is actually working. So let me open the demo. Just a minute. Yes. So what comes in the first demo? I hope you can see it quite well. Let me minimize this. Okay. So now I will demonstrate you this, the activities on the proof of concept. What require the trust establishment? The first activity is the member onboarding, in which the organization sends an onboarding request to the server, to the central server. And when the central server requests the organization to present a business registration credentials for onboarding. So this basically requires, allows them to join the X-Road instance. We can see that the central user interface, let me play again, it was quite quick. Right. Okay, the security server user interface, it is which is interested in joining. We can observe the performance of this security server, which is interested in joining the X-Road network. So basically, once this is established, we can also observe how the wallet itself is populated with the DAD credential. So basically guaranteeing that, illustrating that the onboarding process was executed successfully. Another important activity within this proof of concept is the way of how the messages are being exchanged between the different, how the transactions itself is being executed. Just a minute, let me again to fit the window. Okay. So in this demo, we can observe a member information system, how it consumes another member's service via security server. We use a terminal request to simulate the member's information system here, and we set the get book request to the security server proxy API targeting another member's DAD. After this request is being sent and received, two security servers, they basically request and exchange these credentials. And basically then everything is like being authenticated. We can see like both the request and we see the response. And then all the message exchanges, records, they are being signed with the authentication keys within these DAD documents. So now we see also the aspect of another server, and then we also can verify that all these signatures, they are being provided within the both of the parties. So this was a short illustration, a short demo of the proof of the concept. Let's go back to the final remarks. And my final remarks basically comes on the estimation on how good or bad both of these systems are. So to evaluate the system's quality, we use the identity management system quality assessment model. And the evaluation results showed that the proneness of the high-risk threats, such as the denial of service, reply attacks, basically decreases since because of the use of the distributed ledger, and it helps to reduce the load of from the single machine. And then the security of the system basically goes up. Next, using the decentralized identifiers reduces the time required for the credential insurance due to the key rotation. And as a result, the reliability of the system, it also contributes to the increase of its usage. Finally, both organizations responsibility over the credentials and controls of the privacy also have increased due to the use of the SSI credentials. So, to conclude this presentation, what I have given to you, I have presented you a use case on the X-Road, and I have illustrated on how to implement the organization's identity management using the self-sovereign identity principles. It uses the DKI, which helps to address some of the scalability issues of the PKI. And also it improves the identity, control over identity, and mitigates the single point of failure within the analyzed system. If you're interested more in this work, I encourage you to check the thesis by the Long, which is on the distributed public ledger infrastructure for the trust management in the X-Road, which was defended last year. You can access the document from this link. You can access the code from this GitHub. If you're interested in another perspective of the presenting and maybe more detailed presentation of this work, there is the YouTube created in there. And basically the results of this work, which I have presented to you, they are published in these two articles, in these two papers, one in the SAC conference last year, another one is the ARES conference in Warsaw on the SP2I. And also further, as we follow up work in this project, we have worked on the yet another work, seeing on how we can improve the authentication and the identification management within the X-Road. So this year we have presented the paper on the securing organization identity through the distributed key management. And if you're interested in the new results and a little bit different approach on how to deal with the key management and how to deal with the identity, I encourage you to look for the new paper from the Kaiser conference. Thank you for your attention. Please join us at follow us at the CHESS project. And thank you for attention. I will be happy to discuss later on the questions if they have come.
Thank you very much, Raimundas. Very informative. If you can put the links you mentioned in the chat, I think that the participants will be happy to have them. Thank you. And we have Marcus Sabadello with us. Very happy to have you here, Marcus. And Marcus is a SEEBLOCKS fellow as well. And he will be talking about DEEDs, that are centralized identifiers. So I put the spotlight at you, and you can share your presentation, Marcus, now. Thank you.
Yes, I will share my screen. And yeah, let's get started. So thank you very much for the opportunity to be here and to present. I'm Marcus Sabatello, founder of a startup called Tech in Vienna, and been doing a lot of work on decentralized identity, specifically DEEDs, and also been involved in the standardization of that technology. And Raimundas has already mentioned DEEDs and explained DEEDs a little bit, so I'll try to maybe not repeat things, but focus on some other aspects. The webinar is called DPKI, right? Decentralized Public Key Infrastructure. We wrote a paper back in 2015 at a workshop called Rebooting the Web of Trust. which was I think an early attempt to formulate the vision and to describe how DPKI is an important idea and how moving away from the traditional certificate authority model to a more decentralized public key infrastructure would be desirable. And so this paper lays out some of the rationale and also the ideology a little bit of decentralization and self-sovereign identity, which Raimundas has also mentioned. I have some quotes here from that paper that I think are still relevant today. So it says, the principal can be given direct control and ownership of a globally readable identifier, linking an identifier's lookup value to the latest and most correct public keys. And no single third party can compromise the integrity and security of the system as a whole, is what this is supposed to say. So these were some of the early ideas for DPKI. When it comes to deeds, from my personal deed-centric perspective, I would say that deeds are sort of the realization or the manifestation of this idea, right? With my personal background, I see DPKI as a concept and then also a certain idea and ideology, and deeds as a concrete technical realization. And one thing that's important to understand in deeds, you have these so-called deed methods, right? So deeds are identifiers that are designed to be decentralized, persistent, cryptographically verifiable, and resolvable. But there's no single technology that's used to realize and to implement deeds. And instead, there are these different methods, there are different mechanisms, different underlying systems, how a deed can be created and used. So some of them are based on blockchains and some of them are not based on blockchains. In the early days of decentralized identifiers, there was a strong interest in blockchains. So the first few deed methods, types of deeds that the community worked on were based on a blockchain. And in the previous talks, we've heard about Hyperledger Fabric, Ethereum. So deeds can be built on top of those technologies, but there are also types of deeds that have nothing to do with blockchain. Here are a few more examples. Maybe won't go too much into detail here, but basically there are different ecosystems, different blockchains, different decentralized networks that can be used for creating deeds and for managing deeds. And as Raimundas has explained, deeds are sort of the basis for other things, right? These are identifiers, and they are then used for verifiable credentials and for data exchange and for communication and for authentication protocols and things like that. But deeds at the core are basically a new type of identifier. And let's see, we've also had in the previous talk a little bit about the deed documents. So one aspect of deeds is that they can be resolved. That means if you have a deed, then there's a well-defined mechanism how you can resolve it, how you can look up the associated public keys and other technical metadata. As a basis for other things, so as a basis for verifiable credentials, for signing things and so on. But this is the core functionality. You have a DID, an identifier that's independent of a central authority, but still it provides a way how you can look up the technical metadata associated with it. That's called DID resolution. And I have this slide which I find quite interesting. So comparing DIDs to other identifiers like UUIDs, nicknames, domain names. There are also DOIs and so on, other types of identifiers that can be resolved, or identifiers that are persistent. But to my knowledge, DIDs are sort of the only standardized type of identifier that is both decentralized and resolvable. And I think that's the ideal technical basis for DPKI, right? So the idea to create a public key infrastructure without a centralized authority, but it can still be resolved. And DIDs are valid URIs. right? So these are there's a URI scheme, DID column, and then there's the actual DID. Okay, now a little bit about the standardization and the current state and next steps. So DIDs are already a W3C standard. They were approved in 2022. There's the decentralized identifier 1.0 W3C recommendation. There are also a few other specifications, a few other documents that were produced by the DID working group, including an implementation guide, DID specification registries. This is for extensions, registering extensions to DIDs. And there's some early work on specifications called DID resolution and DID registration. Those are not standards yet. Those are draft documents. And right now, at the moment, there's a new DID working group. So that started a few months ago and is now meeting regularly at W3C. And that will basically do two things, this new DID working group. It will maintain and fix or improve a little bit the existing DID standard, so decentralized identifiers. And this should actually say 1.1, right? So today we have decentralized identifiers 1.0, and the new working group will work on decentralized identifiers 1.1. It will not add major new features, but it will maintain and improve the existing specification. And it will create a new standard for DID resolution and DID URL dereferencing. This has been a little bit of a missing building block in DID technology, how exactly, or what are the inputs, what are the outputs, what is the architecture, and what are the interfaces for resolving a DID. So that's what, as I said in the previous slide, there's a draft specification for DID resolution, and the plan is now to standardize that part, standardizing DID resolution in addition to DIDs themselves. And again, there will also be other deliverables, again, like an upgraded implementation guide, specification registries, again, this extensibility mechanism, and the DID method rubric. This is also interesting because this is a framework for evaluating different types of DIDs, evaluating different DID methods with regard to how decentralized they are. Because as I said, there are different DID methods, different types of DIDs, and some are more decentralized than others, because decentralized means a lot of different things to a lot of different people. So there's also a work item to create a framework for evaluating the amount of decentralization of certain types of DIDs. And yeah, this started now. This is chartered to run for 2 years. And one big open topic, and this is my last slide already, one open topic is the standardization of individual DID methods. So DIDs themselves are standardized. DID resolution now is going to be standardized, but DID methods are currently not yet being standardized. So again, the DID method is the type of DID. In the previous presentation, I think we saw some DID methods like DID solve based on the sovereign network, or DID ether based on Ethereum. But none of those are actually standardized, and that's been a bit of a controversial topic. Actually, when the first DID standard was approved by W3C, there was a lot of opposition. Some of the major big tech web browser companies formally objected to the DID standard. They said we think that DID should not be a standard because none of these DID methods are standardized, and the argument was that this would create interoperability problems. And there was a long process. These objections were eventually overruled by a process at W3C, and so DIDs were accepted as a W3C standard, but still it kind of left this feeling that there's something missing, and that not only DIDs but also specific DID methods should be standardized. DID ether, DID ion, DID Indy, and so on, some of those. And this is also still out of scope for this new DID working group. So the new DID working group is not allowed to standardize DID methods, but there is a lot of interest in that now, and there are some recent developments at the moment. Nothing public, nothing official yet, but there are various organizations, including W3C and others, talking to each other to figure out a way to actually standardize some of the DID methods, and this could be a separate working group or some other process that still has to be determined. But that's something that the DID community is aware of and is now trying to address to standardize concrete DID methods, and that will probably be the one of the next steps to do that. And that's it. Thank you very much. I'll be happy to hear from you if you work on DIDs or are interested in participating in the standardization. Just reach out. We're happy to hear from you. Thank you.
Thank you so much, Marcus. It was great indeed, also citing other works and DIDs. And so we are running out of time, but we have a question on the Q&A chat. So if you can briefly address it. Abhishek is asking whether there are some similarities between the in-progress data space architecture and also with Gaia-X that are part of the EU research agenda. So probably, Raimundas, you can address this this question and other in the Q&A chat. You have the question that is.
I think this question goes for Eric, not for me.
Okay, and Marcus is going to, yeah, okay, can answer it. Yes.
I'm sorry if the question is for someone else, then maybe someone else should answer. But my quick answer would be that Gaia-X does use DIDs. So Gaia-X uses this technology and other big European projects as well.
Okay. So just a quick thank you to all of you, as we cannot probably address other questions, but if you have some, you can just write to contact@SEEBLOCKS.eu, and we will distribute the questions and afterwards send you the answers. And just a quick reminder that we are now running the third selection and engagement procedure. So you can apply for the funding. Now just type SEEBLOCKS.eu and then you can find all the information. Thank you so much for joining us today. And we invite you to follow SEEBLOCKS for other webinars and initiatives. Thank you so much.